Welcome all on the e-learning platform initiated by Science Park, Savitribai Phule, Pune University. Today we'll see part 2 of the session Composition of Matter, where we are covering chapter 6 from SSC board and chapter 1 and 2 from CBSE board from standard 9. Let's take a quick recap what we have learned in last video. We saw different phases of matter as solid, liquid, gases, and then we saw different properties of these phases of matter as rigidity, fluidity, compressibility. Then we have also seen the particle level difference between solid, liquid and gases. We learned about another method with which scientists classify matter as mixtures, compounds and elements. Then we saw certain properties and details of elements and saw some interesting examples of elements. Similarly, we learned certain properties of compounds and we learned about some interesting examples of compounds. Similarly, we have seen certain properties of mixtures and their examples. Lastly, we compared mixtures and compounds with different characteristics. In this video, we will cover following subtopics. We'll see what is the exact meaning of solution from chemistry point of view. Then we'll see what is suspension and we'll see difference between solution and suspension as well. We'll see different types of solution as liquid-liquid, gas in gas, solid in solid, gas in liquid, liquid in solid, solid in gas and liquid in gas, so on. And lastly, we'll get to know about molecular formula and valency. Now, based on the size of its largest particles, a mixture can be classified as a solution, suspension or a colloid. A solution is formed when a substances dissolve and form a homogeneous mixture. In a solution, the size of the particles which are dissolving in a solution are always very small. They cannot be filtered once they are dissolved in a solvent. Whereas in a suspension, it is always a heterogeneous mixture and that can be separated and that can separate into layers over a period of time. So this suspension can be filtered and the particles of the solute which are dissolving in the solvent is very large. In case of colloids, the size of the particle is between solution and suspension. So colloid cannot be filtered and colloid is again a heterogeneous mixture. Now let's get to know these terminologies in detail. When a salt is added to water, salt dissolves in water. So here salt is known as a solute. It is a substance that dissolves in the solvent. Here water is known as a solvent. It's a substance, can be a liquid, can be a gas that dissolves the solute. So the final mixture is known as a solution. Just to know it better, what is a solute and what is a solvent, see these pictures. Now here we are adding solid iodine crystals in a beaker where there is plain water in that. Once you mix the iodine crystals well, once you stir it well, you get a clear solution. So the moment you add crystals of iodine, the picture is like this. All the white molecules are molecules of solvent. Those are molecules of water. And the purple lump in between is a crystal of iodine. Now once you stir it vigorously, all the purple molecules disperse well in the mesh of water molecules. So a solution where the solute molecules are dispersed throughout the solvent is called as a solution. In daily chores, in the morning, first thing we do is, you kids drink Bournvita. So what do? You add Bournvita powder in plain milk. So here Bournvita powder is a solute and milk is solvent. Now here I am giving you a small quiz where I have given you certain substances, substance 1 and substance 2. Now here you need to understand which is a solute and which is a solvent here. For example, I have given you carbon dioxide as substance 1 and water as substance 2. And this is the example of a carbonated drink, right? So which is a solvent and which is a solute here? You have to find out, think about it, draw this chart in your notebook, write down your answers, and we'll discuss about it further in the discussion period. Nevertheless, solution can exist in all three states. Solid can also be a solution, liquid can also be a solution, and gas can also be called as a solution. Let's see how. Now in case of solids, brass is a solid solution because brass is an alloy, a mixture of copper and zinc metal. So this is a homogeneous mixture, right? Liquids. When we add sugar in water, it is a liquid solution. So here sugar water is a homogeneous mixture and it is liquid in liquid type of solution. Let's see some example of gas. Air is a gaseous solution. So we know that there are so many components in air. We have nitrogen, oxygen, carbon dioxide, so on and so forth. So air is a homogeneous solution. Now let's summarize all the types of solutions in case of solvent as gas, liquid and solid, and see some examples of those kind of solutions. First we'll see for gas as a solvent. First is solid in gas. Sublimation. So sublimation of camphor vapors. Now here I have written in nitrogen gas. So that is an example of solid in gas type of a solution. Liquid in gas, water vapors in air, mist that we experience in winter and rainy season. Gas in gas mixture solution is a mixture of gases. Wonderful example of that. Let's see about liquids. Now liquid solutions are again of three types: solid in liquid, liquid in liquid, gas in liquid. Solid in liquid is anything that we dissolve in water. We dissolve salt in water, sugar in water, everything is solid in liquid type of a solution. Liquid in liquid, when we mix two miscible solvents with each other, two miscible liquids with each other. Here I have taken example of alcohol in water. Gas in liquid, all the aerated drinks that you love to drink are gas in liquid type of solutions. Let's see about solids. Solid in solid are all the alloys, are homogeneous mixtures of two or more metals, are example of solid in solid type of solution. Liquids in liquid, mercury in zinc, mercury in gold. Now mercury is a metal which is at liquid state at room temperature. So these can be wonderful examples of liquid in liquid type of solution. Now let's see gas in solid. Adsorption of gases on metals, solution of hydrogen in palladium are all gas in solid type of solutions. Let's see some more details about suspension. When a solid does not dissolve in a liquid, a suspension is formed. A suspension is always a mixture in which insoluble particles are suspended in a liquid or gas. For example, sand does not dissolve in water. Therefore, it is a suspension where sand is a solute and water is a solvent. Let's see some more details about colloids. Colloids contain particles in between the small particles in a solution and the larger particles in a suspension. So, colloids never separate into layers. So, colloid cannot be used. So, we cannot separate them by using filter. And colloids are heterogeneous mixtures. Here I have shown you some very good examples of colloid. One of it is milk, then foam that we usually see, fog or smoke, detergents where we form foam out of it, lots of cosmetics, paints, blood in our body is an example of colloid, and aerogel. Finally, let's compare the properties of solution, colloid and suspension. First, we'll see about particle size. As we have discussed earlier, the particle size in solution is less than 1 nanometer, very small. Whereas in colloid it is from 1 to 100 nanometer. And in suspension, the larger particle size we see always more than 100 nanometers. So the appearance of solution is always clear, but the appearance of colloid and suspension is always cloudy. We cannot separate solution, but we can separate suspensions because the bigger particles settle down in a solvent. We cannot separate colloid because these kind of particles, this size is quite stable in solvent. So they suspend in solvent and cannot be separated. Let's see filterability. Solution can pass through the filter paper. Again the colloid passes through the filter paper. But the larger particles in suspension cannot pass through filter paper and we can separate them easily. Let's see effect of beam of light. If we flash a beam of light through solution, colloid and suspension, what will happen? From solution, the light can pass through easily. But in case of colloids, the light will scatter due to little larger size of particle. And in case of suspension, light cannot pass through the suspension solution. Let's see some examples of solution, colloid and suspension. Salt solution is a very good example of solution. Mayonnaise. Have you ever seen how mayonnaise is prepared? Please go ahead and see how mayonnaise is prepared. Or else we'll do this preparation of mayonnaise in Science Park. And muddy water is a great example of suspension. Now after all this, let's get to know more about valency. We have learned about electronic configuration and valency of an atom in earlier session. Now let's revise. Now in the structure of atom, blue dot is a nucleus. The innermost shell, first shell or K shell, can occupy maximum 2 electrons. Then the outer shell called as L shell, and thereafter all the shells L, M, N, so on and so forth. All the outer shells can contain maximum 8 electrons in them. Now if in innermost shell there are 2 electrons, it is called as a duplet. So the innermost shell should always complete its duplet. For all the outer shells, octet needs to be completed. So for the atom to be inert or stable. Therefore, outermost electrons of an atom are always known as valency electrons. These electrons are responsible for reactivity of that element. In other words, number of valence electrons show ability of that atom to form those many numbers of chemical bond. To know the chemical bonds very well, I have shown you these three atoms. The first atom is of hydrogen, second is of helium, and third is of oxygen. Now hydrogen, we all know that there is only one electron which revolves around the central nucleus. Now if I want this hydrogen to react with oxygen, is it possible? And the another option is, I want this helium to react with oxygen. What do you say? Out of hydrogen and helium, which atom will react with oxygen and why? Pause this video here, think about my question and again resume the video. Okay, I'll tell you the answer. Now to know the chemical bonding and reactivity of the atom, we have to see the outermost electrons, valence electrons. Hydrogen has only one electron. It is very reactive. But in case of helium, there are two electrons in the innermost shell and there are only two electrons with helium. So it completes its duplet. So helium is the first element which is inert, the smallest element which is the inert element. So it is not very reactive. So hydrogen will definitely immediately reacts with oxygen. Now let's see the atomic structure of oxygen. Oxygen contains two electrons in the innermost shell. And let's count 1, 2, 3, 4, 5, 6. There are only 6 electrons in the outermost shell of oxygen. So to complete its octet, it needs 2 more electrons. So it will share 1 electron from hydrogen and 1 electron from one more hydrogen to form water, the stable molecule out of hydrogen and oxygen. Now let's get to know what is molecular formula, right? The molecular formula is defined as the symbolic representation of that particular molecule of that substance. So it is the representation of that substance. Other method of writing molecular formula is by knowing valencies of all the individual atoms and then cross multiplying them. To get well versed with molecular formulas of substances, I have given you little task. Now you pause the video here, write down this table in your notebook. Here I have given you some compounds. I have written their names like silicon dioxide, sodium hydroxide, ethane. You have to find out their molecular formulas. Write down their molecular formulas here. After writing the molecular formulas, you will have to write down the constituent elements present in that molecule. And then number of atoms of that particular constituent element should be written here. I'll show you one example. Silicon dioxide, the molecular formula is SiO2, where we all know that Si represents silicon atom and capital O represents oxygen. So how many constituent elements are there in silicon dioxide? There is silicon and there is oxygen. Now here we have to write down number of atoms of constituent elements. Now how many silicon atoms are there? There is only one. And how many oxygen atoms are there? There are 2 oxygen atoms. So this is how you solve this table, and if you find it very interesting, you can go on writing all the compounds that you know. and fill up all the details of that. Let's learn how to write molecular formula by cross multiplication method. To know this, step 1 is writing the constituent element of that compound. So here again I am taking the example of silicon dioxide. So I am writing down the constituent elements as Si and capital O. Then you have to write down the valency below them. So I am writing down the valency of silicon as 4 and valency of oxygen as 2. Thereafter you have to cross multiply these two columns. You have to multiply silicon with 2 and you have to multiply oxygen with 4. Now what will be the answer after cross multiplication? The answer is Si2O4, right? Now the last step is you have to divide this formula by the smallest possible number. Now here the smallest possible number is 2. So can we divide Si2O4 by 2? Yes, we can. So the answer is SiO2. And this is the molecular formula of SiO2. To solve and to write down the molecular formula by cross multiplication method, you have to know different valencies of all the constituent elements. And you can get to know all the valencies by heart just by practicing them.